Welcome to solverfy.
This problem asks us to synthesize each of these 6 molecules. And we're told besides inorganic reagents, we can use hydrocarbons and halides with 6 or fewer carbons. We can use this methyl vinyl ester. And we're told that each synthesis has to use at least one of the carbon-carbon bond forming reactions from the chapter. Okay, so for A, to start, we'll start from bromobenzene. And the first thing to do would be to nitrate the bromobenzene. And so nitric acid and concentrated sulfuric acid is going to give us the nitration product. Okay, and when we reduce that, so hydrogen gas and palladium on carbon, when we reduce that, we will get the amine. So there's no good way to directly add an amine to an aromatic ring. So we add the nitro group and then reduce it. Okay, so now if we treat this with sodium nitrate, hydrochloric acid, and then water, we will replace the amine with a hydroxy group. That doesn't look good. Okay, and so from here, we're going to want to install our methyl ester. And so to do that, strong base, so sodium hydride to deprotonate that hydroxy group, and then methyl iodide to make the methyl ester. Okay. Now, as the problem says, we have to use one of the carbon-carbon bond forming reactions from this chapter. And so we're going to make the lithium cuprate here. And so in order to do that, we will treat this molecule we've just made first with lithium metal and then copper iodide. Okay, and so what we get from that is actually going to be this. So there'll be 2 of these on a copper lithium center. And now we just need to add the rest of the molecule as the alkyl halide. And so the rest of the molecule looks like this. So 1, 2, 3, 4, 2, 3, 4, 5, 6 with a double bond here. And so that's going to be our carbon-carbon bond forming reaction from this chapter. One, 2, 3, 4, 5, 6. Okay. And so the last thing that we need to do is hydrate that alkene. And so to do that, we want the alcohol on the interior of the molecule. So we're looking for the Markovnikov product here. And so we can just use sulfuric acid, and water. Okay, and so we also should note that we would get two enantiomers here, and that is the product that we're looking for. Okay, and so that's just A. There are 5 more parts to this question, and so I am going to try to speed up and talk a little less and just draw the answer. So for B, we'll start from this. We need to add 2 hydroxy groups. So we'll do the osmium tetroxide dihydroxylation. So OSO4 followed by NaHSO3 and water are those conditions. Okay. TBS protect those 2 alcohols that we just installed. Okay. Now we can again use the copper lithium chemistry from this chapter, just like in part A. And of course, this shouldn't be bromine. There we go. So 2 of these on a copper lithium center. And now we just need to add the rest of the molecule here. And so the rest of this molecule looks like this. And so that gets us to here. And so the last thing that we need to do is take those TBS groups off. And so we can do that with TBAF, which is tetrabutyl ammonium fluoride. You will commonly see it abbreviated TBAF. And so that will regenerate our hydroxy groups. Okay, so there we go. There's our final product for B. C is thankfully a very short problem. So C will start from this. It's terminal alkyne. We use catechol borane. Okay, and so the product of that is going to look like this. Okay, and now we can do our carbon-carbon bond forming reaction. Okay, so that's part C. Part D is going to also be pretty short. So again, we'll start from bromobenzene like we did in part A. And this time we will use a Friedel-Crafts reaction to add what we need. And then from here, we can do a Heck coupling. And TEA here, remember, is triethylamine. So that's another common abbreviation that you'll see. Okay, and so that's going to get us to our final product for D, which looks like this. Okay, E and F are also pretty straightforward. So for E, again, we'll start from bromobenzene. And this time, we'll actually just start with the coupling reaction. It's a terrible looking 6-membered ring. Try again. Okay, and then the last thing that we need to do here is the carbene type reaction that we learned in this chapter. And so It's going to be with this zinc copper species. Okay, and so that forms cyclopropane ring. Okay, and we actually can include some stereochemistry here. So that would look like this. And we'd get both enantiomers. So we should say plus enantiomer. So we'll get a racemic mixture there. Okay, and lastly, part F. So for part F, again, we're going to take advantage of the lithium copper chemistry that we learned in this chapter. So again, treatment with lithium and then copper iodide. Gets us to here. And then we can do a coupling reaction with an alkyl halide. And in this case, the alkyl halide that we want is just going to be bromocyclohexane. Okay, and so gets us to here. And the last thing that we need to do is install an epoxide where that alkene is. And so MCPBA is the reagent that we know that can do that. So there's our epoxide, and we would get to enantiomers here. Okay, so I do apologize for this being such a long video. These are 6 somewhat complex syntheses. So here on page 4 is E and F, page 3, C and D, and then B here on page 2, and A on page 1. And that's the answer to chapter 26, problem number 49.